expression for potential energy. So, the work done against the force of gravity in lifting a body. The work done in lifting a body against the force of gravity is stored in the form of potential energy. This work done itself is stored in the form of potential energy. Okay. For this, let us consider a body of mass m which is lifted to a height h. Which is lifted to a height h. Against the force of gravity. So, gravity, you know the children, the direction of acceleration due to gravity will be in the downward direction, whereas this body is lifted in the upward direction. So, against gravity it is been lifted through some distance, say height h. The distance it has moved is taken as h. Okay, so this work done in lifting the body against the force of gravity is stored in the form of work done. So, what is the formula? General formula for work done is equals to F dot S, children. We know that it is. But we know the value of force. Generally, force is equals to mass into acceleration. But if it is lifted according to against the force of gravity, means F is equals to mg. F is equals to against the force of gravity. F is equals to mg. And the distance through which it is moved. How much distance it is moved, children? To a height h. So, substituting the values in the above equation, W is found to be F is replaced with mg and S is replaced with h. So, work done is equals to mgh, and this work done is stored in the form of potential energy. Therefore, work done in lifting a body against the force of gravity is stored in the form of potential energy. Hence, the formula for potential energy is equals to PE, simply represented as PE, which is equals to mgh. So, this work is done against the force of gravity. Is that point clear, children? Well, so the things on which this potential energy depends is, one is it depends upon the weight of the body as well as the height through which the body is displaced. So, potential energy depends on two factors. One is the weight of the body and the other is height through which the body is being displaced. Got it, children? And one more thing, children, as this work is done against the force of gravity, the other name of potential energy can also be called as your gravitational potential energy. So, it can also be called as gravitational potential energy. That clear? So, one more thing regarding the points that to be remembered regarding the potential energy are, so first one, remember that potential energy is always stored in the body. This potential energy is always stored in the body. So, potential energy is always stored in the body. Okay. And one more thing, children, this potential energy also called as your gravitational potential energy. Is also called as a work done in lifting a body which is stored in the form of potential energy is called as gravitational potential energy. Similarly, during the spring cases and all, this work done due to the change in shapes and all, compressed spring and extended spring, that is called as elastic potential energy. Work done against gravity stored as gravitational potential energy. Work done by the changing shape of the spring is stored in the form of elastic potential energy. And always remember children, whenever the body is lifted upwards, as and when the height of the body is being increasing from the ground, so as the height increases from the ground, the potential energy also increases. If H increases, potential energy also increases. If the value of the H decreases, potential energy also decreases. And the potential energy of the body on the surface of the earth is taken as 0. Potential energy on the surface of the earth is taken as 0. Potential energy always increases as the value of H increases and decreases as the value of H decreases. Are these points clear, children? If yes, let us try to understand few more concepts regarding this. Okay, so this is all about your kinetic energy and potential energy. Now let us move to the next level of energy, that is mechanical energy. So as I have told you in the beginning that mechanical energy is the sum of potential energy as well as kinetic energy. Okay, so this mechanical energy is the combination of both. That means by virtue of motion as well as by virtue of its position or shape. So now let us consider the examples of mechanical energy. The examples of mechanical energy are, the thing is, suppose if you consider a flying bird or an flying aeroplane. So this bird or an aeroplane are at certain height from the ground. So as they are at some height, because of their virtue of its position, they possess potential energy. Whereas as they are moving, they are flying in the air at some height, because of their motion, by virtue of its motion, they also possess kinetic energy. So the flying bird as well as the flying aeroplane possess both energies, that is potential energy as well as your kinetic energy. Similarly, a man climbing a hill. So his position is also changing because he is at certain height and he is in motion. So a person climbing a hill or a tree also possesses your potential energy as well as kinetic energy. So 3 examples we have considered till far. Similarly, if you consider a body rolling down, something like this. A body rolling down on some inclination, then by virtue of its position, it possesses potential energy, and as it is rolling down, as it is moving forward, it also possesses kinetic energy. Similarly, a freely falling body also possesses potential energy as well as kinetic energy. So, whenever a body possesses both one particular position whenever they are at certain height from above the ground, means they possess potential energy, and when they are in motion, they possess kinetic energy. Hence, the flying bird or an aeroplane, the rolling body, or a person climbing a hill, or all examples of a freely falling body are also examples of your mechanical energy. So I hope the concept is clear, children. Okay. So now moving to the next level of questions based on the problem. So moving to the next question.